In this class, we'll be talking about interest. We'll discuss simple interest and compound interest. Well, that's probably the most important topic in finance. So let's go about it carefully, and we will start with some review of very basic building blocks which lead us to understanding of interest. So first building block is, of course, percent. Percent, symbol percent is the same as the word percent. And the word percent is the same as per hundred. So the word per means for each, and hundred means 100. So in English we have the word century, for example, which is 100 years, because cent means 100. However, in problem solving, it is much more convenient to move to another quantity, which is quantity per one. In this way, 5%, which is 5 per 100, is the same as 0.05 per 1. So we move from measurement per 100 to measurement per 1. That's first building block. And how it is used? Well, if I need to find 5% of 17.25, I have 17.25 ones, and I'll multiply that by 0.05, because I take now 0.05 per each one, and I have 17.25 ones. So 17.25 times 0.05. The answer in this case would be 0.86, rounded to 2 decimals. That's the first building block, the understanding of the notion of percent. The next building block will be percent increase. In percent increase, let's say I have now some amount, $750, increased by 4%. A lot of people would solve this problem by following two-step process. In the first step, they would find 4% of 750. So 0.04 times 750, it's 30. And second step of the process would be to take 750 and add 30 on top, so obtaining $780. And that's a very natural way to think about percent increase. Just find 4%, add it on top of the previous amount. However, this method is not efficient, and that will be very important that we use a different method today, especially for building understanding for compound interest. What is a better way to solve this problem? A better way is to find 104% of 750. This means that we'll take 750 and we'll find then one stands here for 100% and 0.04 stands for 4%. 1 plus 0.04 stands for 104%. So we find 104% of 750. Of course, that will be the same $780. So this part here is very important, even though it's obvious, but it is important to realize that instead of me going into that two-step process, now I have one line solution. And the major advantage of this is that it will allow me to speak about compound processes. By compound processes, I mean this. Let's say I need to calculate percent increase when $750 increased by 4% 20 times. Well, what this means is that I start with the amount which is $750, and then this amount will be increased by 4% 20 times. So each next increase will be happening after the previous increase of 4%. If I didn't update my solution for one line process when I found 104%, and if I followed that two-step process, in order for me to solve this problem, I would have to go into 40 steps to solve this problem. Why 40 steps? Well, first I would have to increase 750 by 4%. So I find 4% of 750, it's 30, add it on top, which is 780. Then I have to use that 780 as my new base. Again, find 4% of that, add it on top. Again, I'll find 4%, add it on top. So it will have to go for 20 iterations. And definitely that's not a good idea, because 20 times is not really that many. In compound interest problems, you will see that we'll have 80 times or 100 times or even thousands of times. So when we update this technique of solution, all we need to do is to find 104% of 750, right? So that's the first increase. Then I will need to find the second increase, because the second increase will apply to that new increased amount. And then again, and then again, right? So that will happen for 20 times. In mathematics, when I multiply the same number by itself certain number of times, I get an exponent. So what I just have written here can be written as an exponent. You see, as soon as I began to think about increase as finding 104% of the number, I was able to create an exponent. And this exponent allows me to solve this multi-step, seemingly multi-step problem in a very straightforward way. I use now the calculator to compute this, and it's 1643.34. As you can see, it is much more efficient, much faster way to solve this. And it is a crucial moment for us to build our understanding for what is coming to us in terms of compound percent. Okay, so that was another important building block. And finally, we are ready to start speaking about interest. Now, what is interest? Let's say there is some amount of money that you put into the bank. Okay. So you put that amount of money today. So this, after 1 year, this amount of money that you put into the bank will of course stay, right? So when you give your money to the bank, the money will not disappear, hopefully, if the bank doesn't collapse. But on top of that amount, you always will have something else, right? So this blue part is interest. And the amount of money you put into the bank, we will call principal. Principal. By the way, this word principal also has various synonyms. The same principal can be also called present value, or amount invested, or it can be called in various other ways when you solve problems. So the question is, why are you given this extra amount of money, which we call interest? The reason for this is that you are being without your money for 1 year. And being without your money, of course, is inconvenient. And the bank would have to compensate you for that inconvenience, since you cannot buy some products, you cannot invest that money to expand your business. The bank will have to compensate you for that. And that amount of money that the bank would pay to you to compensate you for being without money is what we call interest. Now, interest is not only inflation. Interest is a very complex concept. Interest usually arises in a very complicated way based on supply and demand pressures. Well, one of the most important components which comes into determining how much interest to pay to somebody is risk. The riskier that investment is, the more interest you typically would earn from that investment. Why? Because you don't know exactly if you will get any return at all from that investment. But in order for you, to be enticed to give your money to some risky enterprise, the only way to do it is to entice you by offering some good profit. And believe it or not, even very risky enterprises always attract investors. Why? Because those risky enterprises offer higher interest. Well, in our course, we don't really need to go too much in depth into the discussion how exactly that interest arises in the markets. It's actually a very complicated topic. But we will just say, okay, as soon as you invest your money, you will earn some interest on that investment. Well, let's now proceed to some mathematics of interest. Let's start with a very simple example. So let's say you invest $1,000 for 1 year. Well, how much interest are you supposed to get for that investment? As we already discussed, you're supposed to get some amount of money for you being without your $1,000 for 1 year. Let's say interest is equal to 10% per annum. Interest is equal to 10% per annum. Now, what does the word what does this phrase per annum mean? Okay, that means per year. So you're paid 10% per year. That seems like a very straightforward idea, and it means that interest, which we call I is the interest, will be your $1,000 times 0.1. So, of course, that's going to be $100. In other words, in this case, if interest is 10% per annum, you are getting paid $100 for you not to be with your money for 1 year. As a result, when you actually come to pick up your investment after 1 year, let's call this S. and this S will mean the future value, or the amount of money that you will pick up your original principal together with interest. That will be, of course, 1,000 plus 100, so 1,100. So that's how much money you earn on your original investment, which is $100. In total, you pick up $1,100. Now, that's a pretty straightforward idea, but there are a lot of interesting things around this idea. And in today's class, we'll go into various interesting aspects of this idea. Okay, so let's now think about this problem a little bit deeper. Let's say that you invest $1,000 not for 1 year, but for 2 years. So it's an interesting question now. What happens with your investment over the course of 2 years? Well, it looks like it's pretty straightforward. You invest your $1,000. For each year you are paid $100. Over the course of 2 years you'll be paid $200, right? So if we use that idea and if we calculate this interest, it will be $1,000 times 0.1, which is 10% over the course of the first year. But because there are 2 years, you would multiply it by 2, and you will obtain 1,200. You will obtain $200 as your interest over the 2-year period. And if you are coming to the bank after 2 years to pick up your investment, then it will result in the future value of 1,000 plus 200, which is 1,200. So you will pick up your principal plus you will pick up your interest. It seems like a very straightforward process. You are paid 10% per year. There are 2 years, so you are paid $200 over the course of 2 years. $100 per year. However, if we begin to think deeply about this, you can say, wait a minute, but what if I'm being a little bit smarter about my investment? What if I invest $1,000 for 1 year? It is the same as I increase my $1,000 by 10%, right? So let me write it this way now. What you are doing now is that after 1 year, you're actually taking that amount from the bank and putting it back into the bank, okay? And after you put that amount back into the bank, you will increase it again by 10%. Now, I want you to really pay attention to this part because that's a very important part. Previously, when we began to speak about 2-year investment, we mentioned a situation that you will get $200 over the course of 2 years. Why? How did you do it? Well, you get paid $100 for each year, and there were 2 years. That's why you got paid $200. Now, in this new idea, you decided to take advantage of the interest which has already accumulated over the course of the first year. So 1,000 became 1,100, and that's the amount of money you decided to reinvest. So you came to the bank, you refreshed your account, basically you came to that teller and said, I want my money right now, so the teller gives you 1,100, and now you put that 1,100 back into the bank for another year, and what is happening right now is that you are earning 10% now, not only on your principal for the second year, but also for the interest which you earned over the first year. Okay? So let's think about this a little bit deeper, right? So if I now build a graph. So you start with $1,000. $1,000 becomes $1,100. And then it is $1,100 is invested. So how much money will that become? Well, first $1,000 will give you again $100 interest, but then you get 10% on top of $100 interest as well. And as a result, you will get $1,210. So you could earn $10 extra because you simply reinvested money after 1 year. Okay? So if you actually take a calculator, it is very helpful to write this expression a little bit differently. So you see, the exponent is appearing here because it's multiplication of the same thing, and it's going to be 1,210. So if you decided to be smarter about your investment and reinvest your amount after 1 year, you generated a situation which we call compound interest. You generated compound interest. You compounded your investment, right? You compounded the second year on top of the previous year in terms of earning interest. Okay. However, we will speak about compound interest in more detail shortly, but let's return back to simple interest and speak about simple interest a little bit deeper, okay? Now, in a simple interest scenario, you cannot do the trick that we just discussed. In a simple interest scenario, you would not be given an opportunity to reinvest your money, and your investment will always be locked for the amount of time that you invest. Now, we will talk about simple interest. So this situation is now simple interest only, and I want to create just several formulas which we'll be using in future for simple interest. So as you can already guess, simple interest is computed as principal times rate of the simple interest. That's a rate per year, and that's rate per 1 per year, right? So rate per 1 means that if I have here 10%, so this R small is rate per 1 corresponding to 10%, so this R small is 0.1. But that, if you multiply principal by the rate per 1, you would get interest per year. Then you will need to multiply that by the number of years to get the total interest you would earn over the term of T years. Now, another important formula is simple future value. So this letter S would stand for simple future value. It's the future value, it's the amount you pick up together with interest based on simple interest calculation. So this will be principal times 1 plus RT. Principal times 1 plus RT. Now, why it is the case? Well, because it is principal increased by some rate R for T years, right? So 1 stands for 100%, and then whatever you add on top in terms of increase. If you know just a little bit of algebra, you also will notice that if you open up this bracket using distributive law, so P times 1 is P plus PRT, right? So which means principal plus interest, right? And which makes sense. So principal plus interest is your simple future value. Okay, so now let's consider, using these ideas, let's consider several examples just to explore this idea how and understand how it works, in more complicated examples. Consider this example. $2,000 is invested at the simple interest is invested at the simple interest rate of 2.5% for 6 months. So let's have several parts of this problem. What is the interest? What is the interest earned? What is the interest earned? And B, what is the future value? What is the future value? Okay, so in this problem, pay attention to one thing. When you don't have anything specified after 2.5%, you see, so it says interest rate of 2.5% for 6 months, but we're not aware about this 2.5% in terms of what is that period that 2.5% covers. Is it per year? Is it per month? Is it per day? In computation of interest questions, we always need to know what amount of time the rate is covering. Well, if there is nothing mentioned about the rate, it's always understood that the rate is per annum. So it's PA, per annum. If nothing is mentioned, it's always per annum. If you see PM, so that would mean per month. If you see PD, it means per day. In those cases, you will always have explicit information about the term that the rate covers. Okay, now after we discussed that 2.5% here is per annum, per year, let's answer question A. Well, question A is interest is P times R times T, right? What is our principal? It's 2,000 times rate. So it's 0.025 is the corresponding rate per one. Now, if you just do that, you found 2.5% of $2,000 for a year. But then you need to find how many years in your investment. Now you have 6 months, right? So it's 6 over 12. So you multiply that by, let me just put it in the bracket just to make a point that this part here is the number of years. So 6 months is 6 over 12, 0.5, half year. Okay. So now you can compute that. And it's 25. Very nice number. Okay. 25. So interest in this case is $25. Now B. Well, in part B, we need to find future value. And future value can be found in two ways. First way is very straightforward, which is 2,000 plus 25, it's $2,025. But just for training purposes, let's find it using a formula. So simple future value will be 2,000, your principal, times 1 plus 0.025 times t, which is 6 over 12. And that, of course, will be 2,025. So once again, almost in many problems, you don't really need to use this formula, because once you know your interest, once you know your principal, you just add interest on top of principal and you're done. However, there are problems when it's not possible to do that, and we'll see those problems in future. Okay, so now let me just modify this problem for some other scenarios to show to you how the problem would be modified if there are other scenarios. Let's say if I have this for investment for let's say 5 months. For 5 months. And if so, then how we will modify this solution? Well, the only thing changes right now is time, right? So now it's 5 months, and 5 months means 5 over 12, right? 5 over 12 years. Now you can compute that. It will be different interest, but you got the point. You got the point. This computation is not really significantly different. Now we can also, instead of 5 months, we can say, okay, what if it is, let's say 205 days. How would you modify this calculation? Of course, it will be 205 over 365. Okay, 205 over 365. Okay, of course here also you will have the same modification, right? And of course it's not going to be 25 anymore, right? But you know, just for practice sake, if you want to practice a little bit more, let's compute that too. It's always good to you know, train yourself to compute using a calculator as much as possible, because you become much better during your tests that way. Okay, so that will be 28.08 rounded to 2 decimals, and of course it's going to be 2028.08. So as you can see in simple interest calculations, when you are given some time, you can always prorate that annual interest for that amount of time you have, and find your interest and your simple future value that way. But let's proceed to some other questions right now to see the same idea but from different perspectives. Sarah invested $3,750 on March 15, 2020, and until let's say September 18, 2020. So Sarah invested $3,750 on March 15, 2020, and until September 18, 2020. And again, we'll have the same questions. So first question is interest, and second question will be future value. We need to find interest and future value. Well, in this problem we'll assume that the rate is 2.73. We'll take some more complicated rate, PA, like this. So we assume that the rate is 2.73 PA. Now in this problem, one thing to note is that first of all, we're not given the amount of time directly. We will have to deduct it from the information given. Second thing is that this time you see there is PA, which is, now you know, this rate is per annum. But it doesn't say explicitly that it's a simple interest. Remember, interest also can be compound interest. It's a little bit of a glimpse we already have experienced, right, at the compound interest. But in this case, it doesn't say it is a simple interest. Well, if the problem doesn't say that the interest is simple interest, it is automatically a simple interest, right? Some problems will explicitly mention what kind of interest it is. In some problems you will see, okay, that's simple interest. In some problems you will see that's compound interest. Some problems will mention this rate is compounded monthly, compounded weekly, compounded whatever. But if there is nothing like that mentioned in the problem, then you can assume the rate is simple interest. Now, let's solve this problem. Well, there are many ways for you to compute the number of days between March 15 to September 18. But when you do that, you will need first of all to keep in mind that March 15 is day 0. Your investment starts on March 15, but at that time there is no interest calculated. In financial mathematics, in consumer financial mathematics, the type of financial mathematics we study in this course, there is no interest within one day, right? So if you invest your amount in the beginning of the day and pick up at the end of the day, usually you would not get paid interest for that very short period of time. Interest starts when the time frame is longer than one day. So this March 15 itself is going to be day 0. There is no interest earned over that day. And when the amount is picked up on September 18, you will need to come up, for your solution, you need to come up how many days passed, starting from March 16 as your day first, up to and included September 18. Well, you can use Excel for that. Excel does it in a very straightforward manner. You just plug two numbers in and then subtract, you plug two dates in and then subtract one date from another date, and Excel will give you the number of days. Or there is another way, is to use a table. So many textbooks, for example your textbook, has a table which basically allows you to compute the number of days between dates pretty straightforwardly. In that table you can locate your first date, usually the later date, in this case September 18. The table would show to you how many days passed since the beginning of the year up to September 18. And then you will also find the number of days from the beginning of the year up to March 15. And then you just subtract these two numbers to get the correct number of days. But if you solve this, if you find the number of days between these two dates, you will see it's going to be 187. So there are 187 days between March 15 and September 18, not including March 15, because that March 15 is day 0. Okay, now after you know that, you will easily calculate interest, and interest will be 3,750 times your rate, because as we already discussed, that's going to be your simple rate, and then times 187 divided by 365. Let's calculate this. So this is going to be 52.45 if rounded to 2 decimal places. 52.45 is the interest amount. And if I want to find simple future value, okay, just present various ways to do it. So it's interest plus principal, or it's better just to, it's more appropriate to write like this: principal plus interest. So your principal is 3,750 plus 52.45. Right? So it's 3,802.45. Okay, so that's basically how you approach a problem when you're not exactly given the number of days. You can calculate it separately and then plug that number of days into the problem and find the amount of interest. All right, let's consider another problem. How much time is necessary for 4,000 to grow to 4,500 at 3% PA. So how much time is necessary for 4,000 to grow to 4,500 at 3% PA? We already discussed that when you see 3% PA, it means that the interest is simple because it doesn't mention anything. Again, if this would say something like 3% compounded annually, then keep in mind it's not a simple interest. But we'll talk about compounding in future. But for you now, you already need to get used to it. Get used to reading these problems properly. So now we need to find time. And various problems will ask you for various, various time. Various problems will ask you for various ways to express that time period. For example, sometimes you will be asked for days, sometimes you will be asked for month, years, and so on. So we'll consider various cases here. So how much time is necessary for you, in other words, to earn $500 interest? So interest is, in this case, of course, $500. Why? Because it's 4,500 minus 4,000. So the interest amount is 5,000. Well, because interest is PRT, what is the principal here, right? Let's write it first, and then we will plug it in. So you have 500 equals principal 4,000 times rate 0.03 times t. Okay, so that's part we don't know, t. And let's keep it that way. Regardless of what you're asked, how many days, how many months, and so on, just keep it as t, because that's the simplest and the cleanest way to solve this problem. Okay, so now you can find this t by taking your 500 and dividing by this amount, which is 4,000 times 0.03. Okay, so let's calculate this. It's 4.16666 and so on. So 6 is in period, it will never end, but we will keep as many decimals as possible. Okay, so that's the number of years. Why do I keep as many decimals as possible? Because I still yet have to use this number to calculate maybe how many days or how many months and so on for this investment. Well, let's calculate, for example, number of days. Number of days. All you need to do is take your 4, 1, 6, 6, 6, and so on, right? Whatever is stored in your calculator, and you will multiply by 365. So the answer would be 1520.83. So it takes 1520.83 days. Okay. However, in our financial mathematics problems, we always will round this number up. So we will say that it's actually 1521 day. So we'll say 1521 day. We will round it up. Why do we round up? To ensure that we do hit that necessary amount of interest. Well, when you round this amount up, in fact, this problem becomes a little bit different. So it will be this: how much time is necessary for 4,000 to grow to at least 4,500, right? Because if you round this amount up, it's not that you will get 4,500, you will get 4,500 with just a little bit more. In fact, it is a good idea as a separate exercise. It is a good idea to see how much money we will get if we round up to the whole number of days, just to see how much this rounding affected this solution. Okay? Now, just to practice with this simple future value idea, we'll take our present value, which is 4,000, which is our principal, and 1 plus 0.03 times 1521 divided by 365. Now let's calculate this. So this will be 4,500.05. You see, because you rounded to this whole number of days, you overshot by 5 cents. Now, what we just did, we not only verified how much our rounding affected, the future value, but also we double-checked our calculation. It is important when you solve a problem, as I already mentioned before, to double-check that calculation going backwards and seeing what is happening. Do you hit more or less the same number? Why I say more or less is because of your rounding. Maybe you will not get exactly $4,500. But as long as you understand that your rounding up here affected this future value a little bit, you now know that this calculation is correct. So for the purposes of your financial mathematics class, when you find time, you always need to round up to the next whole period, in this case, next whole day. Now, we found this number of years and then we multiplied by 365 to get the number of days. But if the question was how many months, so you would multiply definitely for 12 and then you would round up for the next whole month. Okay, so that's it for this problem. So Jasmeet invested let's say $2,500 for 175 days. So the question is, was the simple interest rate that allowed him to earn $70 of interest. So Jasmeet invested $2,500 for 175 days. What was the simple interest rate that allowed him to earn $70 of interest amount? In this problem, we need to find the rate. We know how long the investment was for. Well, again, its interest is PRT, right? And all we need to do really is to plug values in. So you have $70 equals to principal, 2,500, times rate. Okay, so that's what we don't know. We don't know rate. And then times time, which is 175 over 365. Now maybe I should make a note here that we always actually divide by 365 when we have days. Why? Well, in some industries, actually, they divide by 252, right? Because these are the number of working days. So if in those industries, interest is not calculated over the weekend, then it would be 252. And of course, 175 also would assume those interest-bearing days. But in our course, we always will divide by 365, unless you encounter a leap year, in which case you will have to divide by 366. So be careful watching for leap years, by the way. In leap years, you always need to take into account that February will have 29 days. And if you have February as part of your investment, so then you have to include that extra day into your calculations, and then you will have to divide the year by 366 days if February was included in that year. Now, if nothing is mentioned, by the way, if nothing is mentioned, so there is no information if it's a leap year or not, it's just 175 days, so we assume it's not a leap year. Okay, we assume it's 365 days. For our purposes, this precision is enough. Okay, returning to this problem. Now we need to find the rate from here. So how do we find the rate? Well, we just take 70 and we divide this equation by everything which we really don't need around R. So we need to free up R. And it's 70 divided by 2,500, and then 175 divided by 365. Of course, always remember to follow BEDMAS in your calculations, right? And BEDMAS is something important for any calculations in our problems. We always assume that you guys already know what BEDMAS is and how it works. So I found that it's 0.0584, right? So that's a rate per one, which is the same as 5.84%, right? So that's 5.84% PA. That's the interest rate for this problem. Okay, so pretty straightforward stuff, which brings us to this, just to review all this, which we so far have done in terms of formulas. We now have the following formulas. So interest is PRT, as simple future value is principal 1 plus RT, right? So you increase principal by that prorated rate. Okay, R, so your interest itself can always be found by dividing by PR, right? And if you want your principal, for example, right? So in this case, you just take I and divide by RT, right? If you want time, so it's going to be I divided by PR. So here there's a PT, right? Yeah. So that's basically pretty, straightforward algebra based on this idea, right? So you can find a rate, you can find principal, you can find time. Okay, but now speaking about the second part. Okay. How can you find your principal based on simple feature value? Again, the same thing. So principal will be simple feature value divided by 1 plus RT. Okay. Now, one thing I need to let you know about this. In mathematics, in high school mathematics, I already told you that probably you learned BADMAS, which is the order of operations, but also you should know some basics about exponents. So if you have some negative exponent, let's say a into the exponent minus n is the same as 1 divided by a exponent n, right? So negative exponent is simply a short way to write division by positive exponent. So a into the power minus n is the same as 1 divided by a into the power n. Using this, we can write the same formula as s times 1 plus RT minus 1. Why? Because 1 plus RT minus 1 in exponent is the same as 1 divided by 1 plus RT, which is the case here, right? So why it is really a convenient thing to have is not only because it's a shorter way to write the expression, but also in our calculation it's much easier to calculate this because I can only take exponent minus 1 instead of me calculating this bottom of the fraction and then taking this simple feature value and dividing by the denominator. It is much simpler to calculate that way, okay? And let me just cleaner write this formula so that you keep it in mind for future. If you would like to pick up $5,000 from a bank in 4.5 months, how much should you invest today at 4.3% PA? So if you would like to pick up $5,000 from a bank in 4.5 months, how much should you invest today at 4.3% PA? So this is the question about present value. And we cannot now use something like this. We cannot say that, okay, you know what, because simple future value is p plus I, right? So simple future value is p plus I. Why don't we just use deduct p from here, which is s minus I? So why don't we just find interest and then take simple future value, which is $5,000, and find present value. Well, the answer is that you cannot find interest. And why? Because in order for you to find interest, you need to know the present value. You need to know the principal. Well, if you don't know the principal, there is no way to find interest. So what do? So the answer is to use another formula, which is P is S 1 plus RT minus 1. So that's how we find principal, right? And that's why this formula is so useful. So we can now find P from here. It is 5,000, 1 plus 0.043, which is your annual rate, times 4.5 divided by 12, and minus 1. Okay, once again I'll tell you, you need to follow Bedmans. Bedmans means brackets first, then exponents, then division, multiplication, addition, subtraction. In this case, we deal with bracket first, and inside brackets, we go for division, multiplication, then addition, then we'll take exponent minus 1, and then we'll multiply by 5,000. So that's pure Bedmans. And you need to train yourself to not make sure that you're not making mistakes in these kind of calculations. So 4.5 divided by 12 first. So I do 4.5 divided by 12 first because I'm inside the bracket, and I do division first. Then I multiply by 0.043 plus 1. So after I divide this, I multiply by 0.043 plus 1. Exponent. I take exponent negative 1. And then I multiply by 5,000. So the answer is 4,920.65. So that's my principal, and the answer is that's the amount of money rounded to 2 decimals that you must invest for 4.5 months for you to get $5,000. By the way, it is a good idea to check. So let's check, not only for the sake of checking, but also to see how much rounding affected our future value. So we take 4,920.65, 1 plus, so I find now future value, 0.043, which gives you extra practice as well with finding simple future value. Times 4.5 divided by 12. So try computing this. 4.5 divided by 12 times 0.043 plus 1 times 4,920.65. So I get 4,999.995 right? So if I round, of course, it will be exactly $5,000, but just a little bit of rounding of our principal resulted not in exact $5,000, but rounded to 2 decimals, it will be exactly $5,000. So this problem shows how important it is to know that simple present value formula. It is time for us to proceed to compound interest. I think that topic, compound interest, is maybe the most important topic in finance. Not only in your course, not only in mathematics of finance, compound interest is at the heart of finance in general. So it's important to understand this topic very well. Okay, so what is this topic about? Well, remember how when we calculated simple future value, it is principal invested 1 plus RT. So in that case, you will get interest on top of your principal prorated by the amount of time invested. Okay, let's consider a very simple example and remind ourselves how this simple interest would work and how we would modify that structure to get compound interest. We already had a discussion like this very shortly before in one of our examples, but let's revisit that. Okay, so let's imagine that you invest $500 at, I think it's more helpful to take a bigger amount, let's say $5,000 at 4% PA for 4 years. As we already discussed, if nothing is mentioned here, if it's PA, we're talking about simple interest in this case. But also, as we discussed, if you're given simple interest, that simple interest will be locked, right? So that amount, 4 years, your term of investment will be locked for you to, to reinvest amounts during that time. What if your account was not locked? What if you were allowed to reinvest your money? So what you could do is, for example, you could take $5,000 and invest at 4% per year, right? Yeah. So for 1 year. So you take $5,000, invest at 4% per year for 1 year at first. So that's how much money you would get after 1 year of investment. That's the simple future value of $5,000 invested for 1 year. But now, because there are 4 years in your investment term, and because the account is no longer locked, you could reinvest this amount. And you would, for example, let's take an example when you reinvest every year, right? So you take $5,000, invest for the first year, then you reinvest again, and then you reinvest again, and then you reinvest again. So you reinvest that amount 4 times. So you should realize what's happening here, right? So first, $5,000 grows for the first year, then whatever that becomes grows for another year, then whatever that becomes grows for the 3rd year and for the 4th year. Okay? And maybe just to make it absolutely clear, so this is after 1 year, and this is after 2 years, and this is after 3 years, and this is after 4 years. Okay. Now, if I rewrite this part as exponent, if I use exponent to write the same thing, you will see that it will be simply exponent 4 here. But keep in mind in this process, when you reinvest the amount, you take advantage of the accumulated interest to get even more interest, right? Because after 1 year, you already will get some interest, and that interest can be put back into your investment to accumulate interest for another year. 1.04 exponent 4 times 5,000. So this will become 5,849.29. So if you reinvest your amount every year for 4 years, it will be 5,849.29. But if you didn't reinvest, if you just went along with this simple interest arrangement. So if you basically ignore the fact that the account is no longer locked and you just continue with this as though it is locked, you would actually not earn as much interest as you probably could by reinvesting. So if you didn't reinvest, if you just calculated your simple future value, so the calculation would be like this, right? So 5,001 plus 0.04, which is the rate, times 4, which is 4 years, right? So that will be 5,800. 5,800. You see, just going with simple interest for 4 years without reinvesting would give you less interest, which is almost $50 less. Now, so what we just did, we reinvested every year, right? So let me write this. We reinvested every year, which means that we compounded annually. So reinvesting every year is the same as compounding annually. That's just another term, which is a very important term. But the idea here is that we compounded interest annually, right? We invested at simple interest for each year, but we took advantage of the interest accumulated over the course of the year. But here's the interesting thing. So what if we compounded not annually but more frequently, let's say every half year? So you would use the same situation now, but you decided, okay, the account is not locked, let me compound every half year. Okay, so what you would do, you would take your $5,000, invest first for half year, right? So it's 1 plus 0.04 times 1 over 2. So what does it mean, 1 over 2? It means that you take annual rate 4% and multiply by half year. But let me just write it just a little bit differently, the same thing, but I'll write like this. Why? Because I will want you to get used to some formulas which will be arising later on, right? So this is the same thing. It's $5,000 invested at 4% PA for half year. Then you would reinvest that amount for another half year and another half year and another half year and another half year for 8 years, right? So which means that as your exponent, you will have 2 times 4. Why? Because you reinvest 2 times per year, so this is 2, and you reinvest and you continue that process for 4 years. Okay, so let's see what happens in this case. It's 5,858.30 if rounded to 2 decimals. Okay, so what we just created, we created compounded semi-annually investment or compounded semi-annually rate. We compounded our rate semi-annually. Semi-annually means every half year, right? So, and we, as you can imagine, and as you can notice right now, we actually got higher interest because now we took advantage of our accumulated interest earlier. We didn't wait for the year, we waited only for half year, reinvested that amount, and as a result, we got more interest by that more frequent activity. Okay, but now you can say to yourself, I can be now smarter about this, right? I can reinvest this amount more frequently than just every half year. For example, every quarter. Every quarter. So if you do that every quarter, of course, you will divide here by 4, because after first quarter, which is 3 months, after first quarter, you will find this simple future value of the first quarter, and then you will reinvest it again. So there are 4 quarters in a year, and then you will multiply by 4 years in your investment. Okay. So there are a lot of 4s here, but see, it appears that everything is 4 here, but don't get confused about that, right? So you divide by 4 because there are 4 quarters in a year, and that's your simple future value after this first quarter. And then there are 4 quarters in a year, and there are 4 years in total in your investment. Right? So you can now calculate this again. It is very important that you follow BEDMAS in all these calculations. Again, I'll remind you, so how do you do it following BEDMAS? So you do division first inside the bracket, so you go into the bracket first, BEDMAS, bracket first, do that division first, then addition, then you find exponent, right, of this bracket, and then, so you are done with basically that bracket, right, so then bracket is done, then exponent is done, right, and then you go for that multiplication by $5,000. So what we just did, we created rate which is compounded quarterly. Quarterly. So now this rate is compounded quarterly. You took advantage of that rate every quarter, of that interest accumulated every quarter. Now, we can do the same thing for month too, right? So I'm not going to compute this now. We'll do it in other examples, but now you got the point, I guess, right? So if the rate is compounded every month, so you find simple future value after 1 month, and then there are 12 months in a year, and there are 4 years. So you will get even more interest, and it will be the rate compounded monthly. But you can do that even compounding daily. So it will be 365 times 4, right? So even every day you can compound your interest, and you'll get even higher interest amount. So it's going to be compounded daily. So now let's debrief this a little bit, what we just did, okay? So we had some investment opportunity, which was simple interest opportunity, but the account was not locked. It meant that that account allowed us to reinvest as many times as we want, because the account is not locked. So what we did, we first tried to reinvest every year. Then we realized that if we reinvest more frequently, we can get even more interest. So we kept reinvesting at a more frequent rate. So first we reinvested at every 6 months, so every half year. Then we reinvested every quarter, then every month, then every day. And the most interest you can earn is actually reinvesting every day, so compounded daily. That's the most powerful investment. So let's, just because it's the most interest you can earn, let's compute it just to compare. So it's 5,867.50, right? So this compounded daily rate is giving you the highest interest you can earn for your investment. Why it is the highest? Because, as I already mentioned, you cannot earn interest if you invest within a day, right? So interest only gets accrued only when the investment is longer than 1 day. So therefore, compounded daily gives you the most interest. In this case, as you can see, if you're just following a straightforward process investing at simple interest, you would earn 5,800. But if you go the most frequent possible reinvestment at 365 days per year for 4 years, then you get $67.5 more. When we speak about compound interest, amount invested we will call present value. Present value. So let's say this is present value. Now, if you invest at that present value, so your annual rate of investment, rate per year, we will call J. Okay? So J is annual rate of investment. But also this annual rate of investment is called nominal rate, okay? And that's an important thing to keep in mind. It's nominal rate. So nominal rate is simply annual rate of investment. Okay, so we also will talk about I, and I is periodic rate. Now, what does it mean, periodic rate? Well, periodic rate is the rate you get paid for a period of your investment. So, for example, if your nominal interest rate is 10%, so 0.1 in terms of rate per one, right? So if it's a 10% and if it's J, okay? So then I could be 0.1 divided by 12 if the reinvestment in compounding process is happening every month, okay? So we already talked how you can reinvest your amount every month, every quarter, every half year, and so on. So depending on how frequently you reinvest your investment, so this I, rate per period, will be your nominal rate per year, divided by the number of periods in a year. Okay? Now, therefore, this periodic rate I can be written as J divided by M, okay? And where M is the number of periods in a year, number of reinvestment periods in a year. Now, N also is total number of periods. N is total number of periods. Well, and total number of periods is overall number of periods in all your duration of your investment. So N will be M. It's how many periods per year, how many reinvestment periods per year. Remember, this M is the same M as here, times T, the number of years in total. Okay, so for example, if you reinvest every month for 2 years, so then it will be 12 times 2, right? So your N will be 12 times 2, which is 24. So that will be the total number of periods. But we'll see in examples how this works. But for now, that's the major terminology. And using that terminology, I'm ready now to show you how the formula for compound future value will look like. So future value is present value, is the amount invested, 1 plus I, and exponent n. Okay? So it's future present value, 1 plus that rate per period and exponent n here. Okay. Now, why it is an exponent? Because it's a reinvestment process. You reinvest every period. So basically it means that you multiply by the same bracket every period, and then you get that exponent that way. And I is the rate per period. So within each bracket, you have a simple interest, right? So within each period, it's a simple interest working. But then that simple interest is compounded for n periods. Okay? So that's the major formula that we will need to find compound future value. Okay? Now, how do we find present value from here? Well, present value will be future value divided by 1 plus I n. And as we already spoke when we talked about simple interest, that will be 1 plus I minus n, right? So this minus n simply means that I'm actually dividing by the positive exponent. So that's going to be the major formulas. But if you understand the process behind these formulas should be very natural to you. And the process is reinvestment. You just invest your amount at a simple interest for some period at periodic rate I, and that's it. So compound future value is based on the simple interest. That's very important. It's not something completely new, something completely different from simple interest. It's simply simple interest reinvested. All right, so let's consider some problem to highlight how we will use these formulas. Actually, let's go for a couple of problems. One for future value, one for present value. Okay, let's do this. So some year invested. So $7,000 at 3%. I'll use CM for compounded monthly. Okay, so CM is compounded monthly for 5 years. How much will be in his account at the end of 5 years? Okay, so several things to note here. So the first important thing is that you see here we're told that the rate is compounded monthly. Okay, and that means that this amount, $7,000, will be reinvested by the bank every month for 5 years. You need to keep in mind that when we spoke about compound interest so far, we explored it as a situation when the account was not locked and you reinvested that simple rate yourself. But in reality, the banks will actually do it automatically. And so Samir doesn't have to come to the bank at the end of every month and make that reinvestment. That will happen automatically. Now, let's see how this can be solved using our formula. So future value is present value, 1 plus I, n, right? Okay. Let's look at every component here. So present value is, of course, $7,000. Okay. So then, what is our I? I is the rate per period. We have nominal rate, which is 3%. So we take 0.03 and divide it by 12, because there are 12 months in a year and the rate is compounded monthly. So periodic rate is 3% divided by 12. So another thing we need to look for is total number of periods. So here n as your total number of periods is there are 12 months in a year times 5 years, right? So 60 months is your total number of periods. Okay, so let's just put it all now in our formula. So you see how this will look like. So future value is 7,000, 1 plus 0.03 divided by 12, right? So that's a periodic rate, 0.03 divided by 12. And instead of n, you will find 12 times 5. Okay. I prefer to leave it like that without separate calculation, but it's better to put it all in a formula and then basically compute it. So the answer is 8,131.32. 8,131.32. So that's how this formula would work, in application. Okay, what if I said, okay, the rate is not compounded monthly, but compounded daily? Compounded daily, CD. How would this change? Well, the nominal rate doesn't change, so 3% will stay 3%, but the M will change, so it's 365. And here you will have 365 times 5. Again, let's compute it for practice. So it's 8,132.79, rounded to 2 decimal place. Okay, so the same thing, what if this rate was compounded quarterly? What if it's compounded quarterly? How this will change? Well, you divide here by 4. Here it's 4 times 5. So that's compounded quarterly rate every quarter. Now let's calculate this. This will be 8,128.29. Now, just to have a lot of practice with this, compounded semi-annually now. Like, what is happening here if it's compounded semi-annually? Again, nominal rate doesn't change, but for semi-annual it's going to be 2 here. 2 times 5, right? $8,123.79. Okay, so as you can see, it's very easy to use this formula as long as you understand what's actually happening here, right? You need to find I. Remember that it's periodic rate, so you divide nominal rate by the number of periods, and then you need to find n, which is the total number of periods. If you find that properly, there shouldn't be any issue to find future value. Now, let me just speak now about interest. So what if this problem also asked you what is the amount of interest that Samir would earn. So what is that amount of and we'll keep this problem now compounded semi-annually. So we modified this problem for various compounding. So we'll keep it now compounded semi-annually, and that's the future value for compounded semi-annually rate. Now, what about the amount of interest? You remember when we had simple interest problem, we could use I equals PRT formula. So in this case, we cannot do this. For compound rate, there is no direct formula for calculating interest. In order to find interest, you actually need to find first future value. So the interest calculation is this. It's your future value minus present value, right? So your future value is 8,000. So I'll just write it here, 8,123.79. That will be minus 7,000. Of course, it's 1,123.79 of interest. So that's how you would go about calculating compound interest amount. For our following example, we'll be looking for the present value with compound interest. Okay. So Maxim would like to accumulate $1 million in 20 years. Okay. So that's something I would really like to do. It's just I don't have anything to invest. But in any case, so Maxim would like to accumulate $1 million in 20 years. How much money would he have to invest at 3.5% compounded quarterly? Compounded quarterly. CQ means compounded quarterly. By the way, keep in mind in your problems, not to be confused, CQ means every 3 months. Right? So that's what compounded quarterly is. Quarter is every 3 months. Okay, so in this problem we just need to know how much money must be invested. Okay, so that's the problem for the present value. And present value is future value, 1 plus I minus n is your exponent. Okay? Well, I think that is a pretty straightforward solution now, after you understand how this all works. Okay. 1 plus 0.035 divided by 4, that's rate per quarter, so periodic rate here, your I for every quarter, minus 4 times 20, so minus 80 here. So let's see what the answer is. So the answer is 498,099.59. So 498,099.59. So as you can see, the problem is pretty straightforward. So the only thing, we already made various modifications in the previous problem, what happens if it's not compounded quarterly, compounded monthly, and so on. So you probably will be able already to understand what happens here. I just want to make one small modification here just to for you to see how you would modify your solution. Let's say instead of 20 years, I would say something like 5 years and 7 months. So 5 years and 7 months. 5 years and 7 months. So I want $1 million in 5 years and 7 months. What would happen here? Okay, just for you to understand here, it will be minus 4, which is 4 times per year, times the number of years. But I have now here 7 months as well. So all I need to do is to write in bracket 5 plus 7 over 12, like that. And then I have to follow BEDMAS properly to calculate this. Let me do that. It is 823,191.29, right? So that's what happens if it's 5 years and 7 months. It is important to practice with these calculations using your calculator so that you can always generate reliable answers. But again, you just follow BEDMAS. First bracket, so you evaluate this bracket, you evaluate that bracket. Then you take exponent. So this exponent into in this bracket into another bracket. You just find that exponent. Keep in mind it's a negative sign here, and then it will be multiplied by $1 million. Right? It's BEDMAS is very important. So division first inside brackets, then addition. After you evaluate all brackets, then you will be finding exponent and then multiplication by 1 million. Okay, so what if it's something like this? Just to make sure, just in 5 years, let's say 7 months and 3 days, okay, like that. So 5 years, 7 months, and 3 days. All that you have to end is also 3 over 365, right? Like this. 3 over 365. So you got the point. When you have very complex terms, you simply will modify your t based on those terms. Let's consider now why compound rate is superior to simple rate because of the fact that it can provide flexibility. And flexibility meaning here in terms of reinvestments. Okay, so when it's a simple rate, as I already mentioned, when you give somebody a simple rate, you have to lock that account so that people cannot reinvest and take advantage of more interest. But when it's a compound interest, you don't have to lock your account. And the question is why? Why wouldn't you lock it? Isn't that true that customers can still, reinvest at more frequent intervals and still get for themselves more interest? So let's explore that idea. Okay, so in order to understand that idea, let's just ask this question. Okay, if $5,000 is invested at 4% compounded annually for 6 months, what is the future value? What is the future value? Now, You see, this situation is pretty special, okay? Because when we speak about compounding, we always reinvest after one period is over, then we reinvest to take advantage of the accumulated interest. Now, in this case, you wait only for 6 months, you see, and you don't wait for the whole year, even though the rate is compounded annually here. Now, an interesting observation is that some people say, okay, maybe it should be simple interest that I should use if the period of my investment is less than the compounding period. But the actual, the truth of the matter is that the banks will use a compound rate formula to calculate future value in this case. So formula for compound rate is your present value 1 plus I, n, right? And why the bank will use this? Because that's a compound rate, that's not a simple rate. Even though the period is not complete here, even though the period here is less than the actual compounding period. Well, how they will do it, they'll just say, okay, the present value is $5,000. And then when it's compounded annually rate, your nominal rate is the same as your periodic rate, because the period is 1 year and nominal rate is also for 1 year. So in this case, it will be 0.04. Okay, and total number of periods in this case is 0.5 because it's half year. See, that's the trick. That's the trick. The bank will not use simple interest, even though you are below complete 1 year period. They actually will use compound interest formula. And what it results in is this. So 5,099.02. By the way, this is an interesting example also because it shows that sometimes investing at simple rate is better than investing in compound rate. Like most of the time, of course, compound rate is a better investment. Why? Because when you invest at compound rate, you take advantage of the accumulated interest and you end up with high interest, as we already saw in our examples before. But when you do not wait the complete period, so in this case, for example, if you wait only for part of the period, in fact, simple rate would be a better choice in that case. Okay? So, for example, if you find this using a simple interest formula, it would be 5,001 plus 0.04 times 1 over 2, or 0.5 is the same. Actually, let me write 0.5 so that we are aligned with the above calculation, right? So that actually will be 5,100. So you see, with simple interest, you would end up with a better future value. But that's a very unique situation because you are not waiting for the whole period in this case. Okay? Now, why this situation is so important? This is important because since the bank uses compound interest formula, you will not be able to generate for yourself a better rate by reinvesting more frequently. Let's take this example. You have 5,000 in the account. So you have $5,000 in the account, and how much money can you make in 1 year if you invest at let's say 3% compounded annually. Okay. So it looks like you can yes, the rate is compounded annually, and it looks like you can trick the system by reinvesting every half year. So what if you decided, okay, maybe if I reinvest every half year, maybe I can generate more interest, just like I could do that if this was a simple interest. Okay, let's see what happens. If you take $5,000 and you invest for the first half year, so because that's a compounded annually rate, actually the bank will use compounded formula to find future value for this investment after the first half year. So that's what the bank will do, okay? If you invest $5,000 and then decide to pick that up after half year in order to reinvest for another half year, the bank will use compound future value formula to find future value for that situation. And then if you take that amount now and reinvest for another half year, so the bank again will use compound interest formula for another half year, right? So your process is this. You took $5,000, you invested for the first half year, and then reinvested manually for another half year. Why? Because your goal was to make more interest than the bank intended, maybe, right? Just like you could do if that was a simple interest. But then what happens? The bank actually used compound interest formula, and because when you have some number, right, which is, if you multiply two numbers with different, exponents x and y, so it will be x plus y as your exponent, right? Okay, so therefore the way this will work is that you will end up with $5,000, 1 plus 0.03, 0.5 plus 0.5 is 1, right? And you end up exactly with $5,000, future value of $5,000 at 3% compounded annually for 1 year. Okay. You can realize that there is nothing special about 1 year. If you had, let's say, 3 years here, so it would be, these and if you decided to reinvest every half year, so these brackets would go for, all 3 years, which means that you will have 6 of those brackets, but it doesn't matter. 0.5 plus 0.5 plus 0.5 6 times still would get you exponent 6 in that case, which would be compounded annually investment for 6 years. So there is nothing special about 1 year. What the point is that you cannot trick the system if it's a compound rate. If you reinvest more frequently, you still end up with the same future value as was intended by the future value formula, right? Or which was intended by the bank, and they used future value formula. Just to remind you why you could trick the system if it was PA, if it was, let's say, simple interest, right? If the bank gives you simple interest and doesn't lock your account, the calculation will be different that would be applied for the simple interest. There will be no exponents. The calculation would be that if you invest for half year, so you will have to divide 0.03 by 2, so that will be your future value of the first half year, and then you will reinvest for the second half year, and finally it will be $5,000, 1 plus 0.03 divided by 2, exponent 2, because there are two same brackets here. You see, you end up with compounded semi-annually rate. So the bank intended simple rate, but you made compounded semi-annually rate. So you ended up with a better future value. But as long as the bank gives you compound interest, that will not be possible again, because they will be using compound interest formula, which calls for, that's I here, 3% compounded annually, right? So nominal rate when it's compounded annually is the same as periodic rate, and exponents reflect the time when you reinvest. But because of the way exponents work, you end up with the same future value as the bank intends, which gives a huge benefit of compound rates. And that benefit is that you are getting the future value that is intended for you without the necessity to lock the account for you. So when we give customers compound rate, we don't need to worry about any kind of reinvestments in between the term. That's very flexible. Okay. All right. So that's it in terms of compound and simple rates for now. And bye for now.